It's okay.
Okay, we'll start from. I'll write them down as well. Please keep on writing side by side, okay?
Okay, ma.
And please better turn on the camera.
Ma'am, this device does not have the camera.
Okay, you are using from some other device. Fine, no worries. So, Amir, just to quickly recall on some of the concepts. See, we discussed that an atom either loses or gains the electrons, yes or no?
Yes, ma'am.
So now clearly when there are two different categories of the behavior of the atom to gain stability, it might gain the electrons, it might lose the electrons. Clearly there are different categories of the properties that the element shows or that the atom shows. The elements which have a certain property, okay, they are referred to as metals. The elements which have a certain property, they are referred to as non-metals. Now, the properties between the metals and non-metals are different because of the behavior, because of the difference in their behavior. Okay. The elements which tend to lose the electrons, okay, are referred to as metals. And the properties of metals are because of the losing of electrons. The elements which tend to gain the electrons are referred to as non-metals. The properties of the non-metals are because of the gaining of electrons. I hope this point is clear. Amit, yes or no, beta, please respond.
Yes, ma'am.
Okay, fine. So the first point, based on this, we have different properties between metals and non-metals. Quickly, we will discuss them. See, the first property for metal is that metals they are generally lustrous. Yes or no? Lustrous means they have a shine on them. Okay. Always with the properties which I use the term generally because there are always exceptions present. Okay. Whereas non-metals they are not lustrous. Okay.
Yes, ma'am.
An exception to non-metals, okay, an exception to non-metal is iodine. Iodine is a non-metal, but it is lustrous. It shows the shining effect, okay? Please keep on noting the exceptions,
Yes, ma'am.
very important. Is it clear? Second is sonorous. The metals, they are sonorous. I hope you know the meaning of sonorous. Sonorous means when anything is
Yes, ma'am.
beaten, they produce a specific sound. Very good. So non-metals, they are generally not sonorous. The third one is that metals, they are malleable and ductile. Okay. Generally, non-metals, they are not malleable and ductile. We will quickly discuss it here only. Which metal is the most ductile and most malleable, beta? Mm-hmm.
Yes, ma'am.
Beta, it is silver and gold generally, which are most ductile, okay, and most malleable. So the most ductile is silver, that is Au and Ag, okay, silver and gold. Is it clear, beta?
Yes, ma'am.
I think there is a lag in between. Okay, no worries.
And
So
probably the
yeah,
connection here is not that well.
okay, fine, no worries. The metals, beta, please recall that metals generally they are hard, okay. Metals they are generally hard. Now, an exception, very important, Amir, very important is that sodium and potassium. They are also metals, very reactive metals, but they are not hard. Sodium and potassium, they can be cut with a knife. Okay, they are that soft. So sodium and potassium, they are an exception to this. Could be cut with a knife, therefore they are soft. Okay, please write it down. See, they are solid, but they are soft. Being soft does not change them into any other state. They are yet solid. I hope you are able to understand the difference. Okay.
Yes, ma'am.
So all the alkali metals generally sodium, potassium, also lithium beta, that is also soft. Is it clear?
Yes, ma'am.
Non-metals they are generally brittle. You understand the meaning of brittle, beta?
Yes, ma'am. Easy to break, I think.
No, no, no. See, brittle means, see, one thing is hard and one thing can be soft, okay? But it will not lose the texture. Example, you would have seen the clay. Have you seen clay?
Yes, ma'am.
Yes. It is soft. It is not hard, but it is soft, right?
Yes, ma'am.
But brittle, it is not brittle. Brittle means something when force is applied, it will change to the powdery form. It will change to the powder. Yes or
Okay.
no?
Yes.
Example, sand or soil, something like that. A rock, a mud rock. Okay. If you apply pressure onto it, it will change to a very powdery form.
Yes, ma'am.
Yes. So non-metals, they are not soft, but rather they are brittle. Please, very important. Okay. Again, beta, we have exception to this. See, diamond is the hardest substance present. Okay. Hardest natural substance present. Exception diamond, and diamond is an element of carbon. Graphite also is hard. Okay, so these are hard and these are exceptions to non-metal. Amir beta, yes or no? Please respond.
Yes, ma'am. Yes.
Okay, can I discuss the next one?
Yes, ma'am.
See, metals, they are generally solid beta. And please, whenever we say the state, that is at room temperature. Okay, and what is the room temperature beta?
Yes, ma'am. 25 degrees Celsius.
Yeah, it's also taken as 25 or 27 degrees Celsius. Okay.
Okay. Yes,
So
ma'am.
in Kelvin, 298 or 300 Kelvin, that is the room temperature. Whenever we are measuring the state, that is always at the room temperature. Okay. So if I say solids are, I mean metals are solid at room temperature, that is at room temperature. If I can reduce the temperature of, or if I can increase the temperature, they will not be solid anymore. Okay.
Yes, ma'am.
Very important exception to this is mercury, which is liquid at room temperature. Okay. Liquid at room temperature. Done, Amir?
Yes, ma'am.
In case of non-metals beta, they are not solid at room temperature. Generally, they are gaseous. Generally, they are gaseous. Okay. Example: oxygen, nitrogen, all of these, chlorine. Okay. Generally gaseous. And beta, liquid, only one non-metal is there, which is liquid. That is bromine. Okay. Bromine is liquid at room temperature. At room temperature. Okay.
Okay.
And if I ask you, is there any solid non-metal exception? Yes or no? Do you think of any non-metal which is solid, beta?
Mm.
Beta diamond, yes.
Oh, yes, ma'am.
Diamond, graphite, at times sulfur. Okay. So, but even if you write diamond, that's fine. Clear, Amir?
Yes, ma'am.
6 point, beta. 6 point. Metals are generally good conductors of heat and electricity. And which metal is the best conductor of heat? Can you tell me, beta, specifically for heat? Silver and copper.
Okay.
Silver is Ag and copper is Cu.
Yes, ma'am.
Fine. Achha, there are also exceptions here, beta. Mercury and lead. Okay. These are two nonmetals which do not conduct heat and electricity.
That's lead and mercury, right?
Yes, beta. Hg is for mercury, Pb is for lead.
Okay.
These do not conduct heat and electricity.
Okay, ma'am.
Yeah. And one important point here is that because the metals, they are good conductors of heat and electricity, the electrical wiring, they are made up of metals. Yes, copper wiring all
Yes, ma'am.
around us. Yes. And they have a coating of PVC, that is polyvinyl chloride. Okay, beta, they have a coating of PVC, polyvinyl chloride. This is an insulator, and that is to protect us from any harmful effects. Okay. It is also called as PVC. This is a plastic coating onto the wires.
Okay.
Fine. See here, beta. Non-metals, they are generally, never say insulators, okay? They are generally not good conductors of heat and electricity. Okay? They are generally not good conductors of heat and electricity. One very important exception here, Amir, is that graphite, which is a non-metal, which is an element of carbon, is a good conductor of heat. Okay, is a good conductor of heat.
Okay, ma'am.
I hope these points are absolutely clear. Any problem in this?
No, ma'am. Clear.
Yes. So when metals, how many points have we written? 6 or 7? 6. Okay. 7 point, beta. Okay. Yeah. When solids, beta, when they are solid, therefore generally they will be hard. Yes. If they are solid and if they are hard, generally their density will be greater. Yes. So high density. Please use the word generally. High density. And if they are solid, if they are hard, if they have high densities, obviously they will have high melting and boiling points. Yes or no?
Yes, ma'am.
Okay. And the opposite is the case of non-metals, generally low density, low boiling point, and no melting point.
Okay, ma'am.
Yes. Am I done?
Yes, ma'am. Done.
Okay. See, beta, some points are very important. Now, can you tell me, based on the properties that we have discussed, can you tell me the boiling and the melting point of mercury, will it be low or will it be high? Mercury.
I think low, ma'am.
Very good. Because it is not a solid state. Wonderful. Can you tell me, will mercury be liquid at room temperature or will it be liquid at all the temperatures?
Room temperature, right?
Okay, can you tell me, do you think that mercury will attain a solid state at some temperature? Can you tell me yes or no?
Yes, ma'am.
Yeah. So around a temperature of minus 38 degrees Celsius, okay? Actually, minus 38 degrees Celsius is the melting point of mercury. That means at that temperature, it will melt. Below that temperature, it will remain into a solid state. Clear?
Yes, ma'am. Clear.
Fine. The next important point here is that allotropes. What are allotropes, Amir? Any idea, beta?
No, ma'am. Are they like a combination?
No, no. See, beta, I just now said that diamond is an element of carbon. Yes, beta. Also, I told you that graphite is made up of carbon-carbon bonding. That means both of them are elements of carbon. Yes.
Yes, ma'am.
See, a diamond and graphite are allotropes of carbon. Okay. That means carbon, in both the cases, carbon is present, but different type of bonding, different number of carbon atoms are present. Therefore, these are called as allotropes of carbon. Okay. There's
Okay.
one more allotrope of carbon, that is fullerenes, not fluorine, beta, that is fullerenes. That is not in your syllabus. We just have two kinds of allotropes of carbon in your syllabus, that is diamond and graphite. Therefore, diamond and graphite are the allotropes of carbon. Is it clear?
Yes, ma'am.
And third very important point is that I want to ask you, do you have any idea as to why metals are generally good conductors of heat and electricity?
Because of the atomic composition.
Okay, and what is their atomic composition, beta? See, you are right. They are very good conductors of electricity because they have free electrons in them. Yes. Why do they have free electrons in them? Because clearly they have a tendency to lose the electrons. Therefore, those becomes the carrier of the electricity. Is it clear?
Yes, ma'am.
The second is that why are they good conductors of heat? That is because, beta, in case of metals, when they are generally in the solid state, the intermolecular spaces between them is less. Yes. The vibration here, if you are able to recall it from the class 9th lecture, I mean the class 9th concepts first chapter, is that the particles of a matter, they are in continuous movement. And what kind of movement do the particles of matter show, beta? They vibrate. They vibrate, okay? So when the particles of metals, which is in the solid state, they vibrate, the transfer of energy is very easy, okay? Therefore, metals are good conductors. Amir, are you joining from some other platform or other device? Hello?
Yes, hello, ma'am.
Have you joined from some other device, beta?
No, ma'am. It just automatically made me join from two
Okay, fine.
devices.
Just let me know if I am audible and if the screen is visible.
Yes, ma'am. But like, the voice is laggy and
Okay, okay.
yeah,
Can you just
little lag.
refresh it, beta?
Yes, ma'am. I'll try.
Okay. Yes. Should I say that? Is it okay now? Yes, Amir. Am I audible and visible? Hello? Who has joined the meeting, beta? Could you please tell me your name? Who is this by the name of iPhone 14?
Yeah, man. Can you?
Is that Abdul? Yes.
Yeah.
Beta, why so late?
Oh, I forgot about the class.
Okay. Just a second. Amir has left the class. He was in the class. Just a second. Abdul, you did not join in the last class also, beta.
When?
The last class. Yes, the 12th of July. You did not join in the class. And I revised all the concepts of that class just now to Amir.
Yeah.
So now please go through them. Okay. Just give me a second so that I can allow others to join. Are your vacations going on, Abdul?
Yes.
So are you in India or are you in some other country right now?
No, no, I'm in the UA only.
Okay. Tell me, Abdul, in the last class when you were there, yes, up till what topic have we discussed? What is
We
the
were
last
discussing
topic
about
discussed?
the shell.
About the shells. Oh, we have discussed quite a much then.
Yeah.
Now tell me, are all the basic concepts clear with you? The shells, the atomic number, the atomic mass, the losing of electrons, the gaining of electrons,
Yeah.
the metals, the non-metals, the metalloids?
Yeah.
Can you tell me, beta, metals, what tendency do they have in case of the atomic configuration?
What?
The metals, what kind of chemical activity do they show? How are, acha, tell me a basic question. How are metals different from non-metals? Can you tell me that?
Yes, yes.
Yeah.
They're like um good conductors in electricity,
Yeah.
and
And
they're like ductile, I think. Mal
yeah.
malleable and
Malleable.
ductile.
Yeah.
And yeah, etc.
Acha, can you tell me these were the properties of metals, right?
Yeah.
Uh, Generally non-metals they have the opposite of these properties. They
Yeah.
are not good conductors, they're not malleable, they're not ductile, right?
Yeah.
But can you tell me why is there a difference or why is there an opposite properties of metals and non-metals? See, metals and non-metals, both of them are elements, yes or no?
Yeah, because they have like
So
different structures.
yeah, and what is that difference in the structure? I want to know that.
It's like atomic structure.
Yeah, but what is the difference in the atomic structure? Can you tell me that?
Um, it's like they lose electrons
Very good, very good, very good.
from positive
Okay.
ions, yeah.
See,
And
they do not lose electrons from positive ions. The metals are elements which have a tendency to lose the electrons, therefore form a positive ion. Okay, that is a cation. Okay, very
yeah,
good. Then the second point.
and then like when non-metals like gain electrons to form like negative ions,
Mm-hmm. Very good.
so there's a difference between
Yeah,
how they like interact with each other.
very, very good. How are they completing their valence shell? Yes,
What?
wonderful. Do you know why do the metals lose electrons and why do the non-metals gain electrons? What is the reason for them for doing so?
Because like they have a fewer electrons in the outer shell
Yeah, very good. But what is the need for them to lose the electrons, even if they're less or more?
to
Like
keep it
that's the
stable.
and what is the stability in terms of atom beta?
Or what?
You are going right. Yeah. What do we mean by stability in terms of atom? What is the stability for an atom?
It's like the balance or like no. Um how do I explain this?
Okay, I'm
I don't
saying
know how
and
to
you tell me
explain
whether
this.
it's right or wrong. Okay.
Yeah.
Do the atoms want their last shell or the valence shell to be to be completely fulfilled? Yes or no?
Um yes.
Is that stability for an atom?
Yeah.
Very good. Can you tell me what do we mean by valence electrons and valency? Are they same or are they different?
Valence or balance?
Valence. Valence electrons
Yeah.
and valency beta.
So valence electrons are like the outermost shell of an atom that participates in
The chemical
chemical
reactions.
bonding.
Very good.
Yeah.
Very good. Yeah.
And what was the other one?
Valency. It's written on the screen beta.
Oh, valency is like the combining of an atom from like a chemical, no, like the combining of an
Capacity.
atom, yeah, capacity of an atom,
Yeah.
especially
So
like how many chemical bonds of an atom can form with the other atoms.
wonderful. Basically, valence shell is there. The last shell of an atom. The electrons present in them is the valence electrons. Yes. And out of those
Yeah,
electrons, the electrons which are participating in the chemical bonding of the atom, those are called as that is referred to as the valency. Yes or no?
yeah.
Fine. Can you tell me the valency for magnesium?
Valency for what?
Magnesium. Just a random question. If
Valency
you
or
know, it's
atom
fine.
number?
Valency.
Um, wait, it was it two?
Yeah. Okay. Now, if the magnesium loses two electrons, what charge will it attain overall?
Positive?
Very good. Wonderful. So basically, your concepts are clear. Are you clear with the atomic mass, Ahmad? Oh, sorry, Abdul. Or should I
Yeah.
revise that part? Else we'll move on further.
Hmm. No, we can move on.
Okay. Can you tell me the atomic mass of magnesium?
Atomic number of magnesium.
Mass.
Atomic mass. What was the atomic mass?
Okay, no worries. If you are not able to recall that, no worries. Can you tell me, beta, there are three subatomic particles for an atom: electrons, protons, and neutrons.
Yeah.
Do all the three subatomic particles of an atom participate or contribute to the mass of the atom? Yes or no?
Yes.
Okay. So you are saying we add the mass of all the electrons present, we add the mass of all the protons present, we add the mass of all the neutrons present in an atom to get the mass of that atom. Is that true?
Yeah.
Actually, that is not the case. When we calculate the atomic mass for an atom, okay, we just calculate the
Yeah.
mass of all the neutrons and all the protons present in that atom. We neglect the mass of the electrons in that atom. Is it clear?
Yeah.
Because the mass of one electron is very negligible in comparison to the mass of one proton or one neutron. Therefore, we only take the masses of all the neutrons and all the protons in the atom to get the mass of that atom. Therefore, the atomic number, can you tell me what is the atomic mass of an atom? How do you define the atomic mass of an atom, beta?
It's like number of protons and neutrons in
Very
the
good.
nucleus.
Yeah. Why is it? Are you able to relate it? Because atomic mass is only through the mass of the neutrons and the protons. Okay.
Yeah.
I hope this clear. Fine.
Yes.
Now, based on that, we have different properties, as you rightly told. First, we have the physical properties between metals and non-metals. Then we have the chemical properties. Now, tell me, Abdul, I have just now discussed the properties of physical properties of metals and non-metals. There's no other student in the class. Would you want me to discuss this again, or should I move forward? Whatever is your call, I'm okay with
Yeah, I
that.
can discuss this.
Okay, fine. See, these are the. I hope you have a pen and a notebook by your side.
Yeah.
So we have understood the chemical configurations of metals and non-metals. Metals, they have a tendency to lose the electrons, therefore they have a properties, okay, which make them metals. Non-metals, they have a
Yeah.
property of they have a tendency of gaining the electrons, therefore they have their set of properties. Wonderful. Now see, metals beta, they are lustrous. What do we mean by lustrous? They have a shining effect on them. Yes.
Yeah.
Non-metals, on the other hand, are not lustrous. Please, beta, make sure of this point whenever you are describing the properties of metals and non-metals, whatever is the case. Always use the term generally because there are always exceptions present. Okay. So we
Yeah.
will say that generally metals they are lustrous, generally non-metals they are not lustrous. Okay.
Yeah.
Please write this exception of iodine, which is a non-metal but is lustrous. Okay. So it is an exception, beta.
Yeah.
Done?
1 second.
Yeah.
Trust not just not
Iodine is the exception. Okay. As it is lustrous.
trust. Done.
Then, beta, second point is metals, they have a property of being sonorous. What do we mean by sonorous? Whenever anything is beaten onto metals, they produce a specific sound. Okay. That property
Yeah.
is called as being sonorous. So metals, they are generally sonorous, whereas non-metals, they are generally not sonorous. Please write it.
So done. Done.
Then the third, very important, as you rightly told, metals, they are generally malleable and ductile. Okay. What is meant by malleability? Malleability is a property of metals wherein when some force is applied or metals are beaten, they are actually converted into thin sheets. Okay. That property is referred to as malleability and metals show this property.
Is not understand.
You did not understand? You should repeat.
No.
Okay,
Yeah.
no worries. When any force is applied or when the metals they are beaten, okay,
Yeah.
they are actually changed into thin sheets. Okay, thin sheets. That property of beating metals to change them into thin sheets, beta. What is it? Thin sheets. Okay.
Yeah.
That property is called as malleability. Okay. And metals, they
Yeah.
show the property of malleability, therefore they are malleable. Is it understood now?
Yeah.
Please write it down. Done, beta.
Yes.
And what do we mean by ductility? See, ductility is again a property of metals. That means when metals they are beaten, they will change into thin wires. What is it? Thin wires. Okay.
Yeah.
Beta, this property is called as ductility, and metals they show this property, therefore they are ductile.
Yeah.
Done.
Yes. Yes.
And the most malleable and ductile metals they are silver and gold. Please write it down. Silver and gold. Ag is for silver, Au is for gold.
Mm,
And out of
mm,
those, can you tell me, beta, gold is the most malleable and ductile. Done.
yeah.
Can I move ahead? Yes. Whereas non-metals, they do not show the property of malleability and ductility, therefore they are not malleable and ductile.
Yeah.
Coming on to the next point. See, metals, they are generally hard. Metals, they are generally hard,
Or
okay? But an exception to this hardness of metals is sodium, potassium, and lithium, okay? Why is it?
yeah.
Because sodium, potassium, and lithium, they could be easily cut down with a knife because they are so soft. They are not hard. These are the
Yeah.
exceptions to the hardness of metals. I hope you have written them. Sodium,
Yeah.
potassium, lithium. Okay. They are also referred to as alkali metals, beta. Alkali metals. What are they referred to as? Alkali metals. Okay.
Yeah.
So they are soft. Then on the other hand, non-metals, they are not hard, they are not even soft. Beta, you understand the meaning of brittle?
Yeah. Yeah.
What is it?
It's not hard or not soft.
Then what is it?
It's like both. It's,
No, 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 no. Listen, listen, listen. Hard, you understand, right? A rock,
yeah.
you understand. Have you seen clay? Have you seen
Yeah.
clay? That is soft, right? That is very soft. That is not hard. Yeah.
Yeah.
But non-metals, they are not even soft. Actually, you must have seen a mud rock. When you press it in your hand, it is actually crushed to that mud and the powder form. Yes or no?
Yeah.
That is what do we mean by brittle. When some force is applied, it is not even hard, it is not even soft, it changes to the powder form. That is what do we mean by brittle. Okay.
Yeah.
What happens when you press clay? It will change the shape, but it will not change to the powder form. That because that is soft. That is not brittle.
Yeah.
On the other hand,
Yeah.
non-metals, they are brittle. I hope you have understood it.
Yes.
An important exception to the brittleness of the non-metals is diamond and graphite. But a diamond and graphite, they are elements, non-metals made up of carbon atoms, okay? And both of them are hard, okay? Both of them are hard. In fact, diamond is the hardest natural substance present, okay?
Yeah. Wait.
Done.
It does not come under the hard section.
Sorry.
Diamond does not come under the hard section.
It does come under the hard section, but it is a non-metal, so it is an exception to that,
Oh, okay. Okay.
okay?
Done. Done.
A- Actually, diamond and graphite, both of them are made up of carbon atoms. So carbon is a
Yeah.
non-metal, therefore diamond and graphite are non-metals. Is it done, beta?
Yeah. Yeah.
Right. The next point is that metals, they are generally solid. And Abdul,